Alright, now having done the quadratic equation and then the cubic equation, we now want to extend the same idea to quadratic equation, which is of degree 4, and to equations of higher degree. So in the case of quadratic equation, if these are the roots alpha, beta, gamma, and delta, then we have similar results that we had earlier on, and that is, first one is the summation of alpha is minus b over a. Number 2, the summation of alpha beta. You have to be very careful, no? For degree 4, summation alpha beta has how many terms? Summation of alpha beta actually has 6 terms for degree 4. Right? And this is c over a. And then the next one is summation of alpha, beta, gamma. How many terms are there for the summation alpha, beta, and gamma? For degree 4, there are actually 4 terms. 4 terms, okay? Alpha, beta, summation of alpha, beta, gamma, there are altogether 4 such terms. You got alpha, beta, gamma, alpha, beta, delta, alpha, gamma, delta, and beta, gamma, delta. You know, there are only 4 of them. And this is actually minus d over a. And lastly, alpha, beta, gamma, delta will be positive e over a. And then if you look back, you want to realize that whenever this is an even degree 4, right? The last one is positive. You can see. Look back again for the case of quadratic alpha beta, the product of the roots, right? For the case of quadratic, it is actually, do you remember? It is positive c over a. For the case of cubic, which is degree 3, right? The product of the 3 roots alpha, beta, and gamma is minus d over a. And for now degree 4, the product of all the roots, okay? The product of all the roots, you have a positive e over a. Right, so this is the case for degree 4. Now we want to extend the same idea for degree n. Okay, in the case of degree n, written like this. These are the coefficients a subscript n, a subscript n minus 1, up to a1 and a0. And then these are the xn, xn minus 1, and so on. So if this equation, which is of degree n, has these roots, you want to know that a similar result holds true. Number 1, the summation of all the roots. Right, the summation of all the roots. If I call them just like that. Okay, summation of all the roots is equals to minus of the second coefficient over the first. Technically, you could have also summation of alpha I j. Okay, alpha I, alpha j. This will be equals to positive of the third coefficient divided by the first, and so on, so on. And then so in between I'm not going to write, but for the last one, okay, the last one, which is the product of all the roots. Okay, how do you write down the product of all the roots? As I told you just now, for degree 4, for the last one where you multiply all the roots, is positive the last divided by the first. For degree 3, if you could recall, right, for degree 3, if you could recall, okay, let me write down for you again. For degree 3, if you're talking about degree 3, say ax cubed plus bx squared plus cx plus d equals to 0, right? Then the alpha, beta, and gamma is minus d over a. I want you to realize that when it's degree 3 odd power, right? For the product of all the roots is a negative. But when it's degree 4 which is even, the product of all the roots, right, is positive. And remember for degree 2, right, if you multiply all the roots, right, it's also positive on the last coefficient over the first. Likewise, for the degree n, you want to be able to write down the product of all the roots, and it will turn out to be this. The last coefficient over the first. Okay, as I said again, you can have summation of all the roots, summation of the pair products, summation of triple products, and so on and so forth. But the rest I didn't write down it. I just keep. Right, so your notes wrote down for you this. Okay. I wrote down one extra. The in between, you can just actually extend it yourself. Right, this for degree n. Alright. Then if this is the equation, whose roots are these. If I ask you to write down the equation whose roots are the reciprocals, for the same equation, if I ask you to write down the equation whose roots are the reciprocal of all these roots, which means I'm asking you to do this. If you refer with me to your notes, right? This is your notes, huh? This is your notes. Okay. Here. Okay. If you want to find a new equation whose roots are the reciprocals, okay? How do you obtain this new equation? Do you remember, like the earlier lower degree, right? You just have to reverse the coefficients to obtain a new equation whose roots are the reciprocals. Okay, so I'm going to write down, your notes has it again, about the about the new equation whose roots are the reciprocals. Okay, maybe I squeeze here. Maybe I change my mind, squeezing here. Okay. Because I didn't have enough space. Okay, so I'm going to write down again. There's going to be -1, the last over the first. Okay, so I'm going to write down here. I'm going to now reverse all the coefficients and write in this now. A0 x n plus a1 x plus a2 x m minus 2 plus ... until a n. This has roots. Okay. Right. Similar thing you have seen in the earlier cases. So with this in mind, let us look at the word example. On the same page, there's the word example. Okay, let's do the word example there. So let me write as example. You are given that you have this power 4, x4 minus 2x cubed, ax squared plus bx plus 4 equals to 0. Okay, so in this question you are given two things now. You are given that summation of alpha square is equals to 12, and then the summation of 1 over alpha is equals to 1. Then the question wants you to find actually the value of a and b. So how do you do it? You want to recall summation of 1 over alpha. If I were to reverse the coefficient to get the equation whose roots are the reciprocal, then this become the first coefficient, this become the second, and the sum of the roots will be minus the second over the first. So now I can say that therefore this one, right, minus b over 4 is equals to 1. So b is equals to minus 4. Right, that settles for b. And then for summation of this one, right, if you could recall, right, summation of alpha square is equals to summation of alpha square minus 2 summation alpha beta, right? And this we are told is equal to 12. Summation alpha, right? For this one, right, summation alpha means minus of minus 2 over 1, so it becomes 2 square. And then this one, right, this one is equals to this over the first coefficient will be a over 1, or just a, again, just a. Therefore, a is equals to minus 4. Right, check my arithmetic, see if I'm correct. Okay, so with this, we want to look at example 2.5. In example 2.5, you have actually the case where it is degree 100, right? Degree 100. And then in this degree 100, you're asked to find the sum of the roots. Okay, I'm going to do it right here. Example 2.5. Again, I'm going to do it right here. Okay, in example 2.5, you are given this example 2.5. You are asked to find the summation of all the roots. It means you are asked to find the summation of alphas. The summation of all the roots, right, is always equals to the second coefficient over the first. Okay? So it's just like that. Then to find the so-called product of all the roots, means you want this. According to this formula is minus 1 to the power 100. The last coefficient is actually 1. The first coefficient is actually 101. So this gives you an answer of 1 over 101. And with this, right, that completes our discussion of the notes for chapter 2.